Hello, my name is Antonio Joma Samuel, student of Torrens University, Australia, Masters of Information Technology Advanced. I am here to present a design paper on web application security, adopting one of the industry's known standard, the Open Web Application Security Project, the OWASP Top 10. I'm adopting this standard because over time it has proven that it doesn't take leniency in ensuring that all pillars of application security are adhered to when developing a web application or any form of application. The core pillars of application security in terms of data confidentiality, integrity, and availability. While using this standard, I'm adopting the Agile methodology for software development lifecycle. I chose Agile because Agile is very thorough in terms of ensuring that an application is well secured from the inception to the coding and to the deployment of the application to the reviews and in fact till the end of any application. It is very thorough. It is that thorough. Yes, why going with a case study of this design paper, I have done some risk assessment and also suggested some mitigation methods to ensure that every areas of the web application in terms of security is being looked into without neglecting any. From the front end, I have suggested that every field is well defined in the terms of in terms of making sure that every field is being assigned to a data type that is appropriate to handle the kind of data that the field is supposed to take. And at the same time, there are some fields that shouldn't be left open. They should be made to be encrypted while transporting the data from the interface level to the backend, which is the database. Now, such data that should go encrypted is the password, the field that we handle the credit card details, and the login details as well, because I'm suggesting this because it won't be nice to leave it open like that, because for code injections and in order to filter the kind of data that goes into a particular field. If you leave it open, then it will allow for any form of a data input, which might end up harming the system when the bad guys, so to say, put in their hacking tools and try to gain access into the system or send in malicious codes through the fields. And so we make sure that the fields are well defined in terms of the length of data they should take and the type of data that should go in there, and in terms of how many times a user is allowed to make a login attempt. I've suggested that there should be an authentication method that should be put in place, and the third-party authentication method, that won't allow the hackers to be able to gain access or to provide such authentications. And another thing I've suggested for the backend while coding the system is that the coders shouldn't allow any form of SQL escaping. Yes, I suggested that because when you allow for SQL escaping, you are telling the firewall to overlook that particular part of the code. You're telling it, okay, look, hey, firewall, this is a known environment, allow it to pass through. If you allow that to happen during your coding, when the software is deployed, hackers can go in with their tools, sending once they see that there is an escaping in your code, they will use their tool to send in malicious codes and make it look like the part that you have escaped. That way, your firewall that you have implemented for the system security will not be able to decipher what is going on there. It will allow you to pass, thinking it is the part that you have escaped, thereby giving the hacker entrance into your system. So I have suggested that there shouldn't be any form of SQL escaping, and at the same time, we will limit human errors to avoid system failure or any form of loopholes from any end to allow the bad guys to come in. And then I also suggested that there should be role assigning there should be rules on the database access according to the roles of every user groups. In this case study, there are 3 user groups: the ordinary group, the accountants group, and the admin managers group. The ordinary group, we have limited access to just mere information like the name and phone number, while the accounts group we have higher access. They'll have access to credit card details so that they can perform their functions that they have been assigned to, while the admin managers we have sole authority, sole right, sole privilege to every aspect of the database of the system generally, because they'll be in charge of monitoring every activity of the system, making sure that they checkmate for suspicious login details, login attempts, suspicious or malicious codes injection, or suspicious search queries and stuff like that. They'll be able to also monitor the activities of other levels to see what they are doing and the stuff that they are implementing, whatever it is that they are running on the system, to make sure that every aspect of every loopholes that might be in the system is being blocked. And then in terms of review, in terms of creating groups that will ensure that the system is being reviewed, and make sure that they limit the inputs that should be allowed to go straight into the database. I suggested that they should provide a frequently asking question page, where they'll put in likely questions that users may want to ask. That way they'll be able to limit the rate at which users ask questions or send mails into the system. That way they'll block some form of malicious codes or phishing attacks from hackers. Implementing these security measures, among others, I have chosen to speak on these few ones. The firewall that I've adopted is the WALAM as a firewall. I chose WALAM because of its flexibility and its seriousness as regards system security. All these and many more are included in my design paper that I've designed. Please, I urge you to go through my paper for more information. Thank you for your time and thank you for watching. God bless.